Hello and welcome back. So we understood at different thresholds we'll get different precisions and recalls. If your application or if your business need is in such a way that you need to get high precision or high recall, you have to choose appropriate threshold. But we no need to worry about choosing the threshold, because precision recall curve will give you a clear picture on what is happening at what threshold. So let us try to look at the code and understand a little bit. So there is a in scikit-learn metrics we have got precision recall curve. This method takes the y values and the predicted values or the decision scores. Okay, the y values and the decision scores, and gives you precisions and recalls at different thresholds. You are getting it, I think. If you look at this graph, this diagram, at different thresholds we have different precisions and recall scores, right? So if you pass your y value and the decision scores, automatically the precision recall curve will take different thresholds and then calculate precisions and recalls at those thresholds. How will it do that? Like this. I have taken a threshold, made prediction, then passed it to precision score and recall score and calculated, like that, right? For every threshold there will be two numbers, one precision and one recall. So this method is going to return three values, three arrays or lists: precision, recalls, precisions, recalls, and thresholds. So if you look at the values, right, there are 33,379 precisions, 33,379 recalls, and 33,378 thresholds. This many thresholds it actually chose and calculated precisions and recalls. If you try to do a graph between decision scores and precisions and recalls, on y-axis I have taken precisions and recalls both, on x-axis I have taken decision scores. At 0 decision score, we know that the algorithm, the model is giving 93% precision and 76% recall, right? So if you look at that, right, 93% precision and maybe 76% recall, somewhere here, right? And then if you look at this graph, right, you can understand at minus 10, the recall, the precision is 0, almost 0, and recall is almost 1. And at 5, the recall is almost kind of 0 and precision is almost kind of 1, right? So if you look at this precision recall trade-off curve, this is called as precision recall trade-off curve, you can find out a threshold which gives you the desired precision or recall. It is not that you get 99% precision and get 0% recall. You should have some recall in there. If you try to get 99% precision, right, the recall may damage your model. So we'll see that in a moment. So using this diagram, you can understand. Or if you have to achieve a 99% precision, you need to write a method like this. In this method, I have chosen some default values for best threshold and best precision. In a loop, I am trying to take different thresholds and make calculate different precisions. When I get better precision than this value, I am going to update the value, and when I achieve the desired precision, I am going to break and come out of the loop. So that's the code there. You have a look at it after watching the video. And I have got 4.309 whatever is the threshold at which I am getting 99% precision. So to really see what's happening there, I have made predictions. What are predictions? The decision score greater than or equal to the threshold. I have got predictions, I passed them to precision score, the method, the actual y value and the predictions. I've got 99% accuracy. So this method actually found the threshold, appropriate threshold where I got the 99% accuracy, 99% precision. When you look at recall, right, it is actually 17%. So the confusion matrix on which the precision and recall are calculated is here. We'll look at confusion matrix in a moment, but let us see. If you have to get 99% recall, we have to write another method, right, which actually starts from here, right? Recall is actually 0 here, and then it actually started increasing. When you decrease the decision score, it is increasing. So I have written that method like this. I have taken the decision scores, a range of 1000 numbers, and then I inversed the array, and then I am actually trying to make predictions at different thresholds from this side, and then I am trying to find the place where I am getting 99% first time. There may be 99%, many 99% here, but first time at what threshold I am getting can be found only this way. So you look at the code and you will understand what's happening there. Minus 8.14, whatever number is the threshold, the decision score at which I got 99% record. So I made predictions again that for each record there is one decision score. If I do this expression, for every record I will get a true or false, that is the prediction, and I am going to compare it with my actual y value, and I have got 13% precision, 99% record. The confusion matrix changed. Because of changing the threshold, the confusion matrix will also change. So now this is how you need to write specific methods to find the threshold at which you get the desired precision or recall. So let us look at the confusion matrix and try to understand a little more about these thresholds and more. So I said that for some problems you need high precision. If you are trying to predict healthy food, an application you are trying to build where the application is trying to predict healthy food, the predictions made by the classifier should be correct always. Right? If it predicted something poisonous as good food, people will die. Right? So the algorithm, the model is going to do lots of damage. Right? So the algorithm should work perfectly. The precision should be high. So suppose that your problem, whatever the 99% accuracy thing is like this, right? Originally, when you took zero threshold, the false positives are 134 and false negatives are 702. What are false positives? Negative records predicted as positive. False negatives, positive records predicted as negative. Right? So here 134 is a too high number. 134 food items which are not good, the model is predicting them as good. Right? This is not good. So you need 99% precision or maybe 100% precision sometimes. So with this threshold, we have got only 4 records, false records. Not good food items are predicted as good, but 518 items it predicted right. Out of 522 positive predictions, only 4 are wrong. That means the model is working good. For the requirement, it depends on the requirement whether our precision should be high or recall should be high. If you built a model and it is making prediction, it is giving some accuracy, it is not the case. In real time, you need to make the model work according to business requirements. For the food prediction model, the model should predict all correctly, most of them correctly. Out of 522 records, the model predicted 518 records correctly. Because of the threshold change, it was able to do that. Model understood something, and the model's understanding is this: using the threshold change, you made the model work the best. But if you see this, right, false negatives increased. In our original model, it is 702 records which are positive predicted as negative. But here there are, there are 2504 records which are positive, but the model predicted as negative. That's okay. The good food predicted as not good is okay, but not good food should not be predicted as good. 134 not good items are predicted as good. That is not right. Even if you know, it is like Indian Penal Code, right? Mistake, an innocent person should not be punished, right? So like that here, right? 134 records which are not good is predicted as good in a zero threshold setup. So we changed the setup to get only 4 records which are not good is being predicted as good. Even though you ignore some good food as not good, that's okay. So that is, according to the requirement, you are playing with the threshold and trying to make the model, work according to the business requirements. If you look at this recall thing, right? If you are trying to predict or predict the probability of a person becoming a heart attack patient, here recall should be high. In your train set, whatever positive records, there are around 3022 records, right? Yes, 3022 records which are positive. Model should predict most of them positive. Then only it is understanding the pattern. The heart attack patients which are existing in the data set, if model is understanding all of them correctly and predicting it, then it is good. The model is good. And any probable candidate will actually predict as heart attack patient. But the problem here is it is predicting which are who are not heart attack patients also heart attack patients here. That's okay, because the people who are predicted to prone to heart attack, right? They may do more exercise, eat well, right? Live, they modify their lifestyle so that it is for their good, right? So when you are trying to improve recall, the false records are being predicted. False records means the people who are not prone to heart attack also are predicted as prone to heart attack. That's okay, because you are just giving a heads up to make the people work out well and make their health better. So these are kinds of different business scenarios where you need to play with threshold and make the model give you the accuracy or the precision and recall scores you wanted. So that's about the detailed explanation on how to achieve the desired precision and recall. Thank you.